Hi everyone, welcome back to all of you on my YouTube channel. I am Ankit Mishra. I am teaching for GATE Chemical Engineering since last 5 years. So I'm making this video in keeping the motivation in the mind that for GATE 2026 as well as various examinations related to chemical engineering for let's say BARC 2026 ONGC and uh, examinations related to BPSC like assistant engineer, which you would have seen the vacancy for 2025, right? So this video will be very helpful for all of you. So first I'll be talking about some concept that I have taught in the last lecture. So here you can see that I have started with the transfer function. So how to define the transfer function? The transfer functions of any process can be defined as the Laplace of output divided by Laplace of input. So if I'm talking about Laplace of output, that should be in the S domain, and again if I'm talking about Laplace of input, it should be in the S domain also. So let's say if it is in T domain, then you have to take the Laplace and you will convert T domain to S domain. That already I have taught you in my first lecture of process dynamics and control here. And let's say here if you see the input is 5 by s square and output is 5 upon s plus 3, and here if you want to calculate the transfer function of process, so you can see the value is output divided by input, that is 5 upon s plus 3 divided by 5 upon s square, and ultimately you will be getting the value 1 upon s square plus s plus 3. After that I have started discussion regarding initial and final value theorem. That is very important concept for process dynamics and control in chemical engineering. So here you will see, let's say if we have input is and which is denoted as x and output is y. So if I want to calculate the initial value of output, that is y t tending to 0, that is called as the initial value, and final value can be written as y t tending to infinity. So what initial value theorem says that if you want to calculate the initial value of any response or the system's output, let's say y t tending to 0, that can be calculated while using, if you have a Laplace of that function in terms of s domain, and you will multiply s into fs at limit s tending to infinity, and you will be able to calculate the initial value of the function. No, sorry, response. Now if you want to calculate the final value of the response, then what is final value? Final value is when t tending to infinity. So limit t tending to infinity by t, that will be equal to limit s tending to 0 s into fs. So this is only valid when output response of the system is stable. So there are limitations of using initial and final value theorem. I'll discuss this limitations later on. First I'll be talking about some numericals based on this particular concept, so that it would be very easy to let you understand these things, that where this particular theorem fails. So first let's say we have a function of fs that is equals to 3 divided by 2s plus 5. So we have a function and we are supposed to calculate what is response y t tending to 0. So that is the initial value, right? Initial value. So how can we calculate? So if I am using initial value theorem, using initial value theorem, what I can write, limit t tending to 0 yt can be written as limit, sorry, if I want to calculate t tending to infinity in this case, sorry for that. So that is final value we are trying, t tending to infinity, and that is the final value. Final value of response. So I can write using final value theorem. So limit t tending to infinity yt, limit t tending to infinity yt can be written as limit s tending to 0 s into ys, right? So ys is given to you, this one is, let's say, ys, that is 3 upon 2s plus 1. So I can write limit s tending to 0 s into 3 upon 2s plus 5, right? So now you can see, if I'll substitute limiting value directly at s tending to 0, so the value will be equals to y 0. So means when t tending to infinity, that is final value, that will be 0. The final value of this function will be 0. So this is how we can use the final value theorem here, using final value theorem to calculate the final value of any particular output, right? So this is one part of the value question. Another thing, let's try to understand how can we use the initial value theorem. That is also important. So let's say in another problem, let's say you have ys that is given to you that is 5 divided by s square into s minus 5, and you are supposed to calculate y t tending to 0. So now if you use the initial value theorem, using initial value theorem, what you can see that limit t tending to 0 yt can be written as limit s tending to infinity s into ys, that is equals to limit s tending to infinity s into what is the value, that is 5 divided by s square into s minus 5. So this s and s will get cancelled out, and finally you will be left with limit s tending to infinity 5 divided by s into s minus 5. Is that clear? So if I'll substitute the value of infinity here in the denominator, so that will be equals to 5 divided by infinity, that is equals to 0. So this response will be the initial value of this response, limit y t tending to 0, that will be equals to 0. Is that clear? So this is how you can use the initial and final value theorem to calculate the initial and final value of any particular response, right? So that is very, very important thing. Now coming to the limitations of final value theorem, right? So every time you won't see that, you'll see there are some circumstances where this initial and final value theorem fails. So just try to understand where this particular theorem fails, that is the limitations of final value theorem. Right, so let's try to understand where. So first I'll be talking about first limitations is roots of denominator of s domain of function ft should be negative and real. So I'll let you know roots of denominator of s domain of function ft should be either negative or real. Negative and real, not or real, negative and real. So let's say you have ft. So if I'll take Laplace transform of ft, so that will give you fs, right? So first you will convert t domain into s domain, and once you have s domain, then you will calculate. Let's say you have s domain fs, that is equals to, let's say 1 upon s plus 4 into s plus 3, right? So now this is denominator, right? This is your denominator, right? Now what is the root of denominator? So first I'll calculate s plus 4 into s plus 3, that will be equals to 0. So the value of s will be equals to minus 4 and minus 3. So now what we see, the roots of denominator is negative, right? So this is a negative value. So means this system will be stable. System will be stable, and the final value theorem and initial value theorem can be used. Here we can use final value and initial value theorem. But let's say second questions can be right here. Let's say your fs, that is equals to 1 upon s minus 4 into s minus 3. Is that clear? So this one is the denominator here. So now first you have to calculate what is the roots of denominator. Roots of that is equals to s minus 4 into s minus 3, that will be equals to 0. So s will be equals to 4 and 3. So here you can see that roots are positive, means the system will be unstable. So system will be unstable, and here we cannot use initial value theorem or final value theorem. So here initial value theorem and final value theorem fail. So what in short form, what we can say, that first we have to see the denominator, and after that we have to calculate the roots of denominator, and if the roots of denominators are negative, if roots of denominator are negative, then definitely the system will be stable and you can use the initial and final value theorem like this particular problem. But if roots are denominator if roots of denominators are negative positive, then you cannot use initial and final value theorem because the system will be unstable, right? So here the initial and final value theorem fails. So that is the one part. Next thing is that if roots of the and here you have seen the roots are real and positive and negative, but second point or second case can be if roots of the denominator are complex, then the real part of roots should be negative in order to use initial value theorem or final value theorem. So here you can see, let's say if roots are complex, right? So then how what will be the scenario? So let's say if you have a function fs that is equals to 3 divided by s square minus 8s plus 25. So what is denominator? Denominator is this one. So what is the roots of denominator? So first we will calculate roots of. So let's try to understand how we can calculate. This is just a simple quadratic equation. Plus 25 that is equals to 0. So s can be written as plus 8 plus minus root over b square minus 4 into 25 divided by 2. So if you'll calculate these things, plus minus root over 64 minus 100 divided by 2, that is equals to 8 plus minus root over minus 36 divided by 2, that is equals to 8 plus minus 6i divided by 2, that is equals to 4 plus minus 3i. So here you can see that s1 and s2 that is equals to 4 plus minus 3i. Is that clear? So but what is the real part? So if I am talking about any complex number 4 plus 3i, so this one is the real part of the complex number, and this one is the imaginary part of the complex number, right? So here what I have told you, if a system has to be stable, then the real part of this denominator should be negative. So here real part is positive, then here you can say here the real part of roots are positive, so system will be unstable and we cannot use initial value theorem or final value theorem, right? But if let's say if roots would have been like minus 4 plus 3i or minus 4 minus 3i, so here in this case what you will see here, roots real part of roots are negative. So here what you see, real part of roots are negative, so we can use initial value theorem or final value theorem. So here we can use the initial and final value theorem. Is that clear? Because real parts of roots are negative. So this is how we can categorize different problem based on the roots, and finally you can calculate the initial value theorem and final value theorem, and we can use the initial and final value theorem, something like that. Is that clear? Okay, great. Now I'll be moving towards some more complicated concept that will be very much useful for coming real problem that will be asked in your GATE examination. So in order to solve that problem, we have to understand how to perform the partial fraction to calculate the Laplace transform of a function. So how we can do these things? So let's say if you have a S domain, and how we can convert this into T domain. That is what I am trying to do here, right? So let's try to understand this particular thing over here. But these kind of things you would have studied in your class 12th standard. The only I'll be telling you how to do this kind of Laplace thing. So let's say if you have S domain, here I'll be teaching you about the inverse Laplace. So let's say how to perform so inverse Laplace transform, where we will be converting to S domain to T domain. Is that clear? So let's try to understand. Let's say we have a function, let's say fs. I'll be teaching these things with the help of example only. So let's say we have a function 3 upon s square minus 4s plus 4. Is that clear? But you want to convert this into T domain. So how will we convert? So if I am taking Laplace of fs, so that will be equals to Laplace of 3 divided by s square minus 4s plus 4. Is that clear? So now these things can be converted as Laplace of 3 divided by s minus 2 whole square. Is that clear? So in that case, if I want to do this partial fraction, let's say 3 upon s minus 2 whole square, that can be written as a upon s minus 2 plus b upon s minus 2 whole square. Is that clear? So finally it can be written as a into s minus 2 plus b divided by s minus 2 whole square. So here you can see 3 upon s minus 2 whole square, that can be written as 2a plus b. These things you would be knowing. So as plus b minus 2a divided by s minus 2 whole square. Is that clear? So now if you compare the coefficient from left and right side, so what you will see, that you will be getting b minus 2a, that is equals to 3 equation first, and since there is no coefficient of s towards in left hand side, so a will be equals to 0. So if a is 0, then you will be getting b will be equals to 3. So you can check the calculation or mathematical thing. I may be wrong, but again this calculation, this is how we do the partial fraction. So finally you have left with Laplace of 3 upon s minus 2 whole square, Laplace of 3 upon so this value can be written as 3 into t into e to the power 2t. Is that clear? 3 into t into e to the power 2t. So this is how we perform this kind of integration. These things. Again, all of these things are based on only your function value. So now again, if you want to perform, let's say Laplace inverse of, let's say Laplace inverse of 1 upon s into s plus 3 whole cube. So first you have to break this function, right? You have to break this function. So here obviously, sorry for that, this is Laplace inverse only. We are performing Laplace inverse, something like that. Here you are converting s domain to t domain, right? So how can we perform? So first this function 1 upon s into s plus 3 whole cube can be written as a upon s plus b upon s plus 3 plus c upon s plus 3 whole square plus again g upon s plus 3 whole cube. Okay, this is how you can write. And after that you can take LCM and you can multiply all of these things, and you can compare the coefficient of various terms of s from left side, and LHS and RHS, and after that you can calculate the value of A, B, C and D. And once you have calculated the value of A, B, C and D, you can write Laplace inverse of 1 upon S plus 1 whole cube. That can be written as Laplace inverse of A divided by S plus Laplace inverse of B divided by S plus 3, again plus Laplace inverse of C divided by S plus 2 whole square, S plus 3 whole square, plus Laplace inverse of D divided by S plus 3 whole cube. So this is how we can perform the Laplace inverse of any particular function, but this is very complicated, and I am not sure about whether they will ask you in GATE examination up to third order, or they won't create or they won't make such kind of problem where you will see there is a third order dynamics of the system and you are supposed to calculate the Laplace inverse. This would be very difficult while solving these kind of questions in 2 minutes in the GATE examination. So they will avoid while solving this kind of question. Right, now coming to some important function here. So these kind of questions have been asked in the GATE examination 3 to 4 times. So that's why these kind of questions becomes very important for GATE as well as your BPSC assistant engineer examination also. So let's say you have a step input. Let's say you have a unit step input. Let's say you have ut. Is that clear? So if I want to plot these things, so how can we plot? So it can be written as u if t minus 0. So if I am subtracting 0 in t, there is no there won't be any change here, right? So let's say if I plot this kind of things here, unit step function. So unit step functions would look like in this way. So here there is a function ft, and after that here you can see there is the functional value something like that, right? And here the magnitude of this function will be equals to 1. That's why this is unit step, and when t equals to 0. Is that clear? So that's why these things can be written. Now you have seen these things, but if say let's say if I want to make, let's say ft is u t minus 4. So how can we draw these things? Magnitude is 1 obviously, so I'll draw a line something like that here, and I'll draw a line something like that. So there will be time axis and there will be your functional value axis, ft and versus t. So if I want to plot these things, so it will be like that. So it will look like that, and the magnitude here is always 1 here because there is no magnitude associated with this particular function. So that's why this value will be 1, but the time will be here 4. Why? Because at t equals to 4, when t is less than 0, when t is less than 4, the functional value will be 0, and when t is greater than 4, the functional value of the function is 1. Why? Because this is a unit step input, right? So this is how these things look like. Now if I am plotting these things, let's say if you have a function ft that is equals to 2 ut minus 4. So how we can plot this thing? This is very important and very fundamental concept. So if this is clear, then next thing will be very easy for you all. So how we can plot these things? So let's say obviously I have told you on x-axis we will be having a time, and on y-axis you will be having a functional value. So here there is a functional value ft, and here this one is the t. Now what is time? When time is t is less than 4, then you have to differentiate between t is less than 4 and t is greater than 4. But here you can see the function is having associated with 2 magnitude. So here this function will go like that, having magnitude 2, and after that t is greater than 4, it will be having value 2, and t is less than 4, it will be having value 0. Is that clear? So this is how this unit step things look like. Is that clear? Okay, now coming to another problem that is very important problem. So let's say next function is ft. I have told you that a step input or is a combination of if there is a combination of or linear combination of input, then how we can plot this thing. So let's say if you have this kind of problem, so let's say 2u t minus 4 plus 4u t minus 6. Is that clear? So at when t is less than 4, there is a step input of magnitude 2, and when t is greater than 4 and t is less than 6, there will be a step input of magnitude 4. So how can you plot these things? So let's try to understand this value. So we have time axis and we have ft. So first we will be having two times, so t equals to 4 and t equals to 6. So at t equals to 4, first we will give a step input of 2 magnitude and it will go to t equals to 6, something like that. So here the magnitude will be equals to 2. Now when it will reach to t equals to 6, what will happen? Again the total magnitude will be 4. So 2, obviously 2 is there, and after that again it will go and get a magnitude of 2. So total magnitude of the step input at t equals to 6 is 4, and after that it will remain as it is, something like that. So here you can see, so this value will be equals to 2 and this value is 2. So overall, if you'll see here in this plot, this value overall will be equals to 4. So here I can say on the y-axis this value is 4 and on y-axis this value is 2. So you would have understood these things, that how we can plot a linear combination of two step input in a single graph and you can get the answer. Sometimes the vice versa can be possible. Sometimes they will give you the graph, and if you'll see get previous year question where they have given the graph and you are supposed to calculate this particular function value, right? So based on this particular curve you can understand, okay, how we can make this kind of question. I hope this is clear to all of you. Now let's try to understand one more problem, and this would be the last problem of this kind. Okay, so let's say we have a function ft that is equals to 6u t minus 5 minus 3u t minus 8. Sorry, I'll write it correctly. My handwriting is not very good, but I'm trying to make these things good here so that it will be very easy for you to understand the problem. So 3u t minus 8, right? So now first you see there is two time, 5 and 8. So first you will be having a y-axis and x-axis, right? So there is x-axis, there is y-axis. So here you will be having ft and here you will be having t. So here we have t equals to 5 and here we have t equals to 8. Is that clear? Now if I am going to t equals to 5, so when time is less than 5, what will happen? The value of magnitude will be 0, and when t is greater than 5, value is 6. So that's why I'll go, and this would be coming up to t equals to 8, right? Because this is a linear combination of two functions. So first we have to see the time, right? So here time is 8 and 5. So 5 to 8 I have to go with a magnitude of here 6. Now at t equals to 6, you have seen there is a magnitude of negative 3, right? So if I'll subtract 6 into 3, so 6 minus 3, so it will lead to 3 only. So here we are giving a minus 3 magnitude, and again it will go like that, something at t equals to 8. So this particular value will be your 3. Is that clear? Okay, so this is how these combinations look like, but here I have only described about the step input. In the next lecture I will be talking about the combination of a step input and ramp input, or some another inputs also that can come, and after that also we will be plotting. I'll be giving you the plot, or there will be a plot, and how can we convert the functional value from the curve. So both questions can be asked. Let's say if gate is asking this to this, then bar can ask this to this, or any assistant in the examinations, any kind of questions can be asked, something like that. Okay, so these kind of concepts are very very important for understanding the future concept in the gate chemical engineering for power process and control. And I hope I tried my best to let you understand all of these questions. So in the next lecture we'll move forward from this particular concept. And at the end I would like to request to all of you that those who have not subscribed my channel, please go subscribe my channel, and don't forget to press bell icon, so that if I'm putting any new video that is very very important for your examination, so you'll get the notification eventually. And please try to share among your group, so that those people who are not aware of this particular YouTube channel where I am putting a quality content over here. Also, if you will see my previous video, there I have solved lots of previous year question, and eventually in GATE 2025 also, if you see my GATE previous year question that I have solved on my YouTube channel, you will see lots of concept that I have discussed in last 1 month came in the GATE 2025. So definitely this video is going to be very very helpful for you, all of you, on my YouTube channel. And obviously you are getting quality content free of cost on my YouTube channel. Okay, thank you, see you in the next lecture.